Thailand's agricultural sector is an absolute powerhouse. It ships incredible produce all around the world. But here's the thing. When your biggest customer is over 1,000 kilometers away, you're not just farming. You're in a high-stakes race against time. So let's get into how data is solving this massive billion-dollar logistics puzzle.
First up, let's just absorb the sheer scale we're talking about. Look at this number. That's 443 billion baht. That's how much agricultural product Thailand sent to just one country, China, in 2021. China is, by a long shot, their most important market. And for a nation where over 7 million families work in agriculture, getting this right, well, it's pretty much everything.
But here's the catch. For the longest time, the cheapest way to ship was by sea. The problem? A trip from a Thai port to, say, Shanghai can take over 6 days. And for fresh fruit and vegetables, that's an eternity. This is a huge headache, especially for farmers in Northeast Thailand, a massive agricultural region that's totally landlocked, miles and miles from any seaport.
And then, in December 2021, everything changed. The China-Laos high-speed railway opened up, and just like that, there was a direct, fast, and super efficient land bridge right to Thailand's doorstep. A journey that used to take days could now be done in hours. I mean, this wasn't just a small improvement, it was a total revolution. A huge opportunity to get fresh food to market faster than ever. But there was still one giant problem to solve. How do you get all that produce from hundreds of farms scattered all over the place to this one railway efficiently?
To figure that out, researchers had to look at the whole region's transportation system in a completely new way. They had to stop seeing it as just, a bunch of roads on a map and start seeing it for what it really is, a complex, living, interconnected network. The core tool they use for this is called network analysis. It's a really powerful way to understand pretty much any system by breaking it down into just two simple things: nodes, which are the key points in the system, and links, which are the connections between those points. Honestly, just think of it like a social network. But instead of people and friendships, we're talking about roads and districts.
And here's exactly how they did it. They took the 20 provinces of Northeast Thailand, and every single district, all 340 of them, became a node. Then every major road connecting them became a link, all 1,015 of them. By translating the physical map into this data network, they could finally analyze its structure and find its hidden weaknesses and its surprising strengths.
So what did they find out? You could almost call it the network's personality test. The researchers ran a bunch of diagnostic tests on this data model, and what they discovered about the road system was, well, pretty fascinating.
Okay, diagnosis number 1. The network is sparse. That's a technical way of saying its network density is really low. In plain English, there just aren't that many direct connections between places. To get from District A to District B, you usually have to zigzag through several others first, which, as you can imagine, creates all sorts of slowdowns and bottlenecks. And that brings us right to diagnosis number 2, low efficiency. The data showed that on average, it takes over 6 different road connections to get between any 2 districts in the region. This measurement, it's called the average path length, basically just confirmed what farmers already knew in their guts. Getting things from point A to point B takes a lot of steps, and it takes a lot of time.
But now, this is where it gets really interesting. This is the twist. Even though the overall network is pretty disconnected, the analysis found something else. It's also highly clustered. What that means is, while it's hard to get from one province to another, the districts inside the same province are actually really well connected to each other. It's like having a bunch of tight-knit local neighborhoods, but no major highways connecting them.
And that discovery, that was the key to the whole thing. The solution wasn't to go out and build hundreds of new roads. No, it was to find the few strategic locations that could act as bridges between these strong local clusters, the superconnectors that could finally tie this whole network together.
Now, to find these superconnectors, the researchers used a metric called centrality, specifically something called betweenness centrality. It's a bit of a mouthful, but the idea is brilliant. It doesn't just count how many roads a district has. Instead, it measures how often a district is on the shortest path between other districts. Think about it like this. A district with high centrality is like a major traffic interchange that everyone has to pass through to get anywhere else. It's not just about having connections. It's about being essential to everyone else's journey.
And the results were pretty eye-opening. The districts that shot to the top of the list, places like Na Khu and Kawawong, they weren't necessarily the biggest cities or the provincial capitals, but the data showed they were the most critical for the flow of traffic. Taking one of them out would be like removing a major bridge from a highway system. It would force everyone to reroute and cause chaos.
These were the hidden linchpins of the entire network.
So this is the big reveal. After crunching all the numbers, the study pinpointed these 8 specific districts. Based on their high connectivity, and crucially, their high centrality, these 8 spots are the absolute ideal locations for regional consolidation hubs, places where produce from all over can be gathered up, processed, and then shot efficiently up north to that new railway.
So this is great, right? But how does a fascinating academic paper like this actually become a practical, real-world economic blueprint? Well, this research isn't just about understanding the network. It's about giving leaders the tools to re-engineer it for massive growth.
And the level of detail they went into is just brilliant. The study didn't just stop at those 8 big regional hubs. They recognized that some farmers would still be too far away. So it also identified the single best consolidation hub for each and every one of the 20 provinces. This creates a really smart 2-tiered system, making sure that farmers everywhere, no matter how remote, can cut their transport costs and plug into this new export superhighway.
So what does this all boil down to? It means that for the very first time, there is a data-driven, strategic map for investment. Instead of just guessing where to build a new warehouse or which road to upgrade, policymakers now have a clear guide. They can direct money and resources to the exact spots that will maximize efficiency and deliver the biggest economic bang for the buck for the entire region.
So, the opportunity is crystal clear. The railway is already built, and now, thanks to network science, the logistical blueprint has been drawn. The only question left is, with all the pieces finally in place, just how fast can this vital economic engine for Thailand really go?